All right, so today we are going to be learning about how to write equations of parabolas. And so far, we have covered two different forms. We looked at factored form, which is going to be in our quiz on Thursday, but we also looked at the vertex form. So what we're going to do is I'm actually going to go over how to write both of the forms for each graph. So the first thing I'm going to do for this one, so this is going to be my example one. And the first form I'm going to look at is going to be factored form. And another way to refer to factored form, sometimes you'll see it's called intercept form. But in factored form, what happens is that we have our x-intercepts give us a factor. And each x-intercept will give us its own factor. On rare occasions, sometimes we have the same x-intercept happen twice, which is what's happening here. So for example, in this equation, the 0 for us is 3, which means that x minus 3 is our factor. And since it's the same exact 0, it is a repeated factor. So we have x minus 3 and another x minus 3. Before we finalize our answer, we have to think about the a value, which is the coefficient in front of x minus 3, x minus 3. And this is what's going to affect the stretchiness, or how thin or narrow or wide this graph is. Okay, so there's two ways to do this. One way is to look at it from a graph perspective. So a quick reminder, when a is 1, and this is something we looked a lot at last class. So from your vertex, if you go 1 to the right, you're going to go 1 up. Now, so let's take a look what happens here. We go 1 to the right, but instead of going 1 up, we actually go 2 up, which is twice as much. So my a value should have been 2. Okay, so that's how you're going to do the a value from the graph. Now, well, I'm going to come back to the algebraic ways. So then we're also going to look at factored form, or vertex form. We need factored form. So let's take a look at vertex form. Okay, so vertex form has, it's going to have this kind of specific template. So in vertex form, you're going to have the x-coordinate of your vertex kind of in the parenthesis. So if you look at this, if your 0 happened at 3, that means you needed x minus 3 in your parenthesis. And then in the homework, we either shifted things up or down. And here, if you notice, nothing is shifted. So technically speaking, it's just plus 0. But we don't even need to write that. You can, but we don't have to. Now, you still have this a value, and it's still 2. And it's not going to affect the vertex itself, it's just going to affect, again, how stretchy or narrow your parabola is. So in this example, I showed you how to get the a value from the graph. I also wanted to show you how you can also do it from algebraic perspective. So what you can choose to do, this is just another option. You could say, pick a point on your graph. So let's say I pick this point, and this is saying when x is 4, y has to be 2. So you can look at your, let's say your factored form, and let's say you did not know the a value. You were clueless and you had no idea. So I'm just going to say a. But I did know this was going to be x minus 3, x minus 3. What we're going to do is we're going to say that we know that if 4 is my input, so everywhere where I had an x, I'm going to put a 4. My answer or my output has to be 2. So this is going to allow you to solve for a. Well, 4 minus 3 is just 1, and 4 minus 3 is just 1. So essentially you get a times 1 times 1. You also get a equals 2. So again, if you notice, it's exactly the same a value that we were able to get from the graph. So it doesn't really matter which method you use, you get the same a value. So it's going to really be more about what do you feel more comfortable with. So these are your answers. Now, when you do your own practice, pay attention to the directions. You don't have to write both forms for each problem. You either will be asked to write factored or intercept form or vertex form. So make sure you're not doing too much work. All right, so let's take a look at another example. So let's take a look at this one. This is going to be our example 2. And just like for the previous one, we're going to do both forms. So we're going to look at factored form for this particular picture. And we're also going to look at vertex form. Again, you will not have to do both for your homework. You just kind of have to pick one or the other. All right, so factored form. So I'm going to start by using my x-intercepts. So I have two x-intercepts. One of them is x minus 7, or x minus 7, or x equals minus 7. So that means that my factor must have been x plus 7, because remember, it's all about what x value makes it equal to 0. So then my other one is negative 5, which means that I have to have x plus 5 as my other factor. And I still have to figure out my a value, right? It's still in front of the parenthesis because it affects how stretchy your graph is. Well, we're going to look at what happened as we moved away from the vertex, right? So remember that when a is 1, when you go 1 right, you go 1 up. So when I go 1 right, I go 2 up. So the vertical distance got multiplied by 2, which means that your coefficient a has to be 2. So this would be your equation for the factored form of this parabola. So now we're going to move on to the vertex form. And in vertex form, we are going to have some sort of kind of like a template, right? So in vertex form, we're first going to think about what happened before we shifted anything up or down. So your parabola used to be over there, okay? Which means that your 0 was negative 6, which means that this had to be x plus 6. Remember, it's all about what makes this equal to 0. And then you notice that we shifted everything down 2, which means that we must have had minus 2 on the outside of the parenthesis. That's what would shift your parabola downwards. Now, we fixed our vertex, but we still have to take into account the a value because that's going to control how stretchy, how narrow or wide your parabola is. And we can totally use our work from the factored form, and a will be the same. It's still going to be 2. Okay, so that is how you would do this from the graph. Now, I want to take a minute and just show you how you can do the same work algebraically. And when I say the same work, I mean getting the a value. So one thing you can do is you can come over here and say, well, I can clearly see that when x is negative 4, my y value is going to be 6. So you can choose whatever form you're working with. So let's say we're working with factored form. You are going to plug in negative 4, and your answer has to be 6. And I'm just kidding because we technically wouldn't know what the a is, right? Because the whole point is we don't know and we're going to try to figure this out. So we're going to just kind of call it a. So we have a, negative 4 plus 7 is 3, negative 4 plus 5 is 1. So we end up having 3a equals 6. So if I divide both sides by 3, I get a equals 2. Again, it's the same exact a value that we have already found. Okay? So it's just a different way of finding it. All right, so here is our last example we're going to look at together. And we are going to, once again, I'm going to do factored form with you. And then I'm also going to do the vertex form with you. And in factored form, you are going to be using each one of your factors to get a parenthesis. So let's say that your 0 is negative 7. That means that x plus 7 had to be one of your factors. Let's say x minus 5 is one of your zeros. That means that x plus 5 was one of your other factors. Now, the other thing we have to do is figure out this a value. Well, let's take a look. When we were at our vertex, when we went 1 to the right, we actually ended up going 1 down, 1 down. And if that happens, that just means my a value is negative 1. So that just means that I need a negative 1 in the front. Okay. So now we're going to take a look at what happens if you were asked to find the vertex form. Well, we're going to start by thinking about where was our parabola before it got shifted up or down. So I'm just going to imagine it being here. So if my vertex is at -6, your parenthesis is going to be x plus 6. And then we're going to figure out how to shift it up, right? So we shifted it up 1 unit. So that means we must have needed a +1 over here. Okay. And then I'm going to get my a value from the graph. So it's a -1 again. And once you figure the a value out, you're pretty much done. And then what I'm going to do is I am going to just show you algebraically how would you figure out the a value if you had to do that. Okay, so I'm going to grab this point right here. So this tells me that if x is -4, y is going to be -3. Now this is not some magic point. You literally can grab any point on your graph as long as you can clearly figure out the x and the y coordinates, and your vertex is going to, just don't use your vertex, because if you use a vertex then the a just kind of goes away because you have a 0 if you use vertex form. Okay, so any point other than vertex or x-intercepts would always work, so it would be always good. Okay, so I'm going to use factored form. So in factored form, again, I don't know the a value, right? So we're pretending we didn't know it was -1 and we're just trying to figure it out. So you have -4 plus 7, -4 plus 5, and your answer is going to be -3. So a multiplied by 3 multiplied by 1 is going to be -3. So that gives us 3a equals to -3, which gives me a equals -1. And that is going to be your a value, the same exact a value that we figured out um, on our from the graph.